We need to run codes where simple things will be running on CPU, but numerical intensive things will go on GPU. Okay. So, there will be CPU and GPU or many cores GPU. So, in Colab I think this is a very good platform, otherwise you need to get hold of a machine with NVIDIA GPUs. We will use CUDA. So, CUDA is for NVIDIA. Okay. For AMD there is a different programming language, similar, but there are ways to convert your CUDA to AMD GPU, but it is a different thing. So, Colab does give you a GPU. Okay. It turns out if you are logged in for long time, they says, well, GPU not allowed anymore. Okay. That is what happens to me. But if you are if you run for the first time, it is available for a while. So, this is a thing everybody must have seen, right? I mean, otherwise I will fail you in the course. You should have used Colab, and Colab has, this is the menu, and in that menu you go to the runtime, and when you click runtime you will get this sub menu. In sub menu, look at change runtime type. Okay. Change runtime type and you will get this window. So, runtime type is Python, you can use other things as well. So, here use this, well, normally it is CPU. Okay. Your thing will be default is CPU, but you have to click T4 GPU. Well, there is only GPU available for free. A100 GPU and V100 GPU are not free. Okay. You need to pay. Says well here, purchase additional compute nodes. Okay. If you have money, dollars, which is expensive, you can purchase. So, T4 GPU is what you can choose. You can also use TPU, but that is for tensor programming for machine learning. Okay. Neural networks uses that, but this does not work for our thing. So, T4 GPU is what you have, and do not keep it on for long, otherwise it will say, well, today's quota is over. So, I could not run in the morning today. So, and save it. You are ready to, I mean, you can, that is it. So, you have access to a GPU and your CUDA codes will run. Okay. So, it is very easy, thanks to Google, it has made GPU programming, it is learning quite easy. Okay. So, let us look at very simple code, hello world. Okay. This is one example which is given all the time. So, everybody I am sure can write the normal C code, right. Hello world is in main and just say print hello world, and that is it. But here I am going to use, so this CUDA.h you can include. Okay. It has some, by the way, these are libraries. CUDA is a library like MPI. So, there are some CUDA functions, all are these things are being executed by CPU. CUDA also has a code, but CPU is telling go and execute that code, and of course, there will be a machine code which will be running on CUDA. Okay. So, but this is CUDA header files, okay, CUDA function header files, and time I am not doing timing right now, but we will do it later. You can time the how much time does it take. So, this you can use earlier whatever we did for C++, no? We had timing, but right now I do not know how to time inside a GPU. Okay. So, I am going to tell you a bit later that part. Time will, do not worry, right now let us focus on how the code works. So, I have this function definition global void is return type, it does not return anything. My kernel is the name of the function, and it also does not take any argument. So, this is a basically dummy function, takes nothing, gives nothing, and it does nothing. Okay. So, it is vacuum. So, this is a dummy function, and I have main program. So, main program, how do I call this function? So, say my kernel is the name of the function comes here. So, this function is supposed to run on a GPU. Okay. I will tell you little bit more. So, you put 3 left arrows and 2 numbers and 3 right arrows and like that. Okay. So, 2 numbers within 3 arrows. This is the function which runs on GPU, because it has a keyword global, in the left, and it tells you that global is a keyword which compiler understands, that this code will be directed by the host. Host is CPU, okay, host main guy in the house, okay, host is CPU, and device is GPU. So, these are keywords, okay, you will see these words very often, host and device. So, this is a function which is directed by the host to run on the device. Okay. So, my kernel is to be running on device, and this is called number of thread blocks and this number of threads. Right now, I just need one block and one thread, that is it. Okay. And print something, this is done by CPU, this is done by CPU. In fact, all of it is basically CPU. This function will run on a GPU, but who is executing that function? CPU. CPU tells that, okay, run it on GPU. Call this, how do I compile it? GCC will not compile it. Right now, GCC is not capable of doing it. Maybe in future it will, I am sure it will, but you use NVCC, NV for NVIDIA, C compiler. And name of the file you keep it separate than C is .cu, CUDA. Okay. This CU is a extension .CUDA, and this will compile, and it creates an object code called a.out, okay, and I run it by .a.out. So, this is done in one line. Okay. Ampersand is adding two commands, okay, and when I run it, I get first CUDA code, okay, my first CUDA code. So, print, this is in fact printed by CPU. We will do more things with GPU in a while, okay, just give me a few minutes. So, let us understand a little bit more. So, this CUDA C++ global, this one keyword is a keyword. It says run from the device, this will running on device, the function, okay, this function will run device, but call from the host. NVCC C compiler. So, it does two things, it creates codes for the host, normal C compilation. So, this is all done in a normal stuff. So, this is host functions like main for CPU, and also device function like my kernel. So, my kernel will be very different object code which will not run on the CPU. Okay. It may use, I will say, well, it will use threads and it will use lot of codes that is not available on CPU. In fact, it is a very different object code. Okay. So, this is what the compiler NVCC is doing. It is free, well, I mean NVCC is free. In fact, you can download, if you have NVIDIA card in your laptop, you can download NVCC compiler and install. So, this my kernel 1. So, this is the name of the function, and this 1. So, triple angle bracket marks a call from the host, from the host to device, okay, or well, I mean from host to device, is also called kernel launch. Okay. So, this the name is called kernel. Okay, this is kernel launch, and okay, this shifted a bit in Microsoft. I write this in Keynote and then I export it to PPT. So, that is why it is a bit. So, first index is blocks, how many blocks I am using and how many threads I am using. So, I am going to tell you about block and thread in the next slide, I think. Okay. So, the one is coming in a minute, okay, just give me a minute. Okay. So, is that clear? So, basically there is one function which is going to be running on GPU. Okay. This one, whether this first thing you need to learn. So, let us look at slightly more complicated code. So, I am going to come to thread and thread block and grid block in few minutes. It is not this slide, but it is coming. So, this code is a bit complicated. I have two integers a and b, I add them and reassign to a. Okay. Looks very trivial, no? Well, it is trivial, but you just need to do it carefully. But this addition and assignment is to be done inside a GPU. That is my task. I got the main code here. This is the main code first. Let us look at the main code. Pay attention. This is what you need to, if you understand this, well, you are starting well. Okay, we have some distance to go, but starting well. So, I create two variables A and B. Okay, this is for CPU. A is 5, B is 9. I create after that two pointers DA and DB. So, D is a short form for device. This small d is a short form for device. Sometimes I use also this D underscore A. So, it is a practice. You can see any code I just copied from. So, this practice to keep these variables specific, host and device. So, host I am not putting any label, but the corresponding object for device you put this div underscore A, div underscore B. Okay. These are pointers, but these are not created inside the CPU or inside the memory of the CPU. I will create it later. I create inside the GPU, right. So, there is no way I can say int DA. Clear, is that clear? No, because I need to put it, create this inside the memory of the GPU. CPU memory is in your laptop CPU memory, but GPU, which is a card, inside that there is a memory. Okay. We need to create here. So, now the next line is what is creating that CUDA malloc. So, here M is capital. Okay. So, CUDA memory allocation, forget about this star double void double star, it is not stuff. Ampersand DA, size of int, I am creating only one number. So, is of 4 bytes, and this DA is a address. Ampersand DA means DA is my variable inside that device, but ampersand DA is a well, basically this tells you DA is a pointer. Okay, that is what is coming. Yeah, so DA is a pointer. Now, some syntax there may be deeper reason, but I do not want to break my head why this ampersand is in there. It just creates a point. This is the pointer. What is it doing? It is allocating storage for my integer inside the GPU, and its address is DA. Okay. Next line I create another integer, its address is DB. I am getting the address by CUDA malloc. Remember, malloc was giving me the pointer, which is the address. So, I am getting these two pointers by this function. Is that okay? I need the address, because otherwise CPU does not know how to do its work, or it is basically on direct GPU to do some computation. It needs to know where the numbers are, and okay. So, that is why I need to create and get the address. Then CUDA mem copy. So, this is CUDA mem copy. These are keywords. You do not want to make a variable of this thing. Okay. So, CUDA mem copy, CPY CUDA mem copy, DA ampersand A. So, A is my integer value 5, its address. So, it needs a pointer. CUDA mem copy also needs a pointer. So, ampersand A will send the pointer. It is passing by reference. Remember, that is what I said. It is basically sending the pointer. Size of int and CUDA mem copy host to device. So, what is it doing? So, let us make this picture nicely. So, this is CPU and this is GPU. GPU has a memory, there are many codes, but it has GPU, and this is CPU also has a memory. Well, not CPU, but my host has a memory. Okay. So, let us call it host, not CPU, host. So, there is a variable A and variable B. So, contents of A and B has to be copied inside the GPU. Okay. So, this is DA and this is DB. So, this is what is being done by these two lines. Okay, CUDA mem copy, and the direction is clear, host to device, host to device. Okay. I am passing two pointers. We will pass arrays as well, okay, later on. So, you do not want to pass the full array. These functions which are memory space, memory intensive, normally we pass the address only. okay, it is not called by value, it is called by reference. After that I am going to call the CUDA function, CUDA int, add integers CUDA. So, this is name of function, it uses one thread block, one thread DA DB, okay, is 1 comma 1, okay, we do not put 1 comma 0, is 1 comma 1, and this is going to add. So, it is going to create A equal to A plus B, and then where is my result? Whether it is there inside the GPU. So, this DA is updated, is it clear? Is updated. Now, what do I do with that number? Can I print it? Well, normally no, a device does not like. So, we need to bring it back to CPU. CPU is the boss needs to know the answer. So, then you CUDA mem copy, this DA is copied back into to A. Okay. So, is in fact is right to left. So, this copy is right to left. Here it is A to DA, A to DA, and here it is DA to A. And you can see that syntax device to host. So, it is coming back to CPU, and I am done. So, print and then CUDA free. So, memory, well, normally it is good idea to free all the memories, especially if A, B will not matter because there are integers, but if you big arrays you free it, if you do not need it, free it. Okay. So, this is how the main program is, but we need to also write the function. So, this is my function global, that means this has to be running inside the GPU, name void, it does not return anything, name of the function, and it is taking 2 pointers, and what is it inside the function? Star A, content of the pointer, okay, what is there at A is address, okay, this A is the address. I mean this A should not be mixed up with this A. So, what is there at the address A is updated by the content. Well, you add star B with star A and update star A. Okay. You should not say A equal to A plus B, that is only updating the address. When I do it, what is the answer I should expect? 5 plus 9, 14. So, answer is 14. Okay. So, but this computation was done inside the GPU.
CUDA memcopy is an inbuilt function.
Is part of CUDA library, CUDA.h is there. Yes.
So, it takes argument keywords CUDA memcopy host to device. This is also inbuilt.
This is a keyword. This is not a variable. It is a keyword or it is a keyword. Like true false, no? These are, you can't use a variable called true or false in Python. Or if is a, if there can't be variable called if, or tag, these are keywords. So, the arguments are 2 pointers, size, and this direction, which way. Yeah.
So, for CUDA, variable A is treated as pointer, and for CPU, the variable A is treated as a value.
Actually, this is I should have probably used x and y. Do not mix up. This is a argument. Argument can have any name. So, ideally I should, well, I think I should have put x y. This A has nothing to do with this A, but this DA and these are, this has to do something. DA is a copy, D is an image of A, but this x and y are nothing to do with this A has nothing to do with this A.
That A is actually DA.
Yes, yes, but I well then I should have put DA, but these are arguments. So, this A is not connected with the CPU at all.
Global is used for GPU.
Global is a very specific meaning. It is executed by, is basically directed by the host to be running inside the GPU. So, global is not, well, global is a function which the function after global keyword will run inside the GPU, but CPU will tell it to do it. So, these functions will run on GPU, okay, that's true. Yeah.
Every time we call the global function, we will have to provide the thread ID and
you need to pass the argument, and argument will be basically address inside the GPU. Okay, that I am coming to it. So, that I will come to it. So, this 1 comma 1 I have not discussed it yet, we will do it soon. Yeah.
So, the part of the code written under global, that is only accessed by GPU.
Actually, compiler will create a GPU object code for this, okay, and that is stored inside the GPU, and that will execute. This will run on, well, it's true, it will run only on GPU, it won't run on CPU.
And the main function written under the function written under main, that is accessed by both CPU and both.
No, GPU doesn't access anything. GPU is just a guy who can do only fast computing. GPU has access to none of these. GPU has only access to this function, that is it. GPU is only one function. Well, when I copying it, of course, GPU is active, something is copied, but GPU is the master when this function is being computed. Okay.
Can you explain that function code, like A star and star, A and star B are addresses, right?
No, A is address, star A is the content of A,
Like the value.
is a value. So, A is address, it has value 5, A is address. Okay. Well, I should have used, in fact, let me use it x and y. So, this will be star x equal to star x plus star y. So, call it x is the address. When I put an arrow, that means this is address. It would be very big number, which is address. Y is also an address, which is, it is at the location that number which is stored is 9. If I say x plus y equal to x, what will I get? My address will be changed, not the number. So, change the number, I need to redirect, go inside. So, put the inside, and that is what I will do.
So then after we have summed those values, we need to put that back in the address.
When I did this, the number is already updated, because it is passed by value, passed by reference. When you give the address, you have given the key to the house. Okay. The guy is changing the variable. This variable is already changed. So, this 9 has become 14. When I did this line, it is already changed. Actually, you people are not, you should know better programming, I would say. Well, recording band hai na bhi. How is typically, let us take an example. Actually, I do not want to spoil this, but I will probably delete that one. So, this function which is given is this temp function. You can write in any language, okay, but let us do it in C. Void exchange int A comma int B. Is it everybody seeing this? So, how will I exchange two numbers? First, copy A to temp, then now A can get B and B can get temp. Okay. So, A equal to 5, B equal to 9, exchange 5 comma 9. Will this code work? Okay, in temp. Will this work? What it does is this A and B. So, here I make a new variable A inside the function. So, A is 5 in the main, B is 9. Well, this I should not be doing it. Okay. These IT graduates should know this part. Otherwise, your AI, ML all are waste if you don't know how to do this. Now, inside the function, these are local variables inside the function. So, this 5 is copied for this variable A. So, inside the function A is copied at 5, B is 9. So, temp will be become, well, temp becomes A, temp becomes 5, A becomes 9, B becomes 5, but it is not copied back. Once the program is done, these are variables are gone, in fact, finished. So, these are unaffected. So, you can't exchange variables like this. So, what do I do? Cause by reference, and you look at the C book. Okay, I mean, you guys should revise your C, not for this course, but for yourself. You put this reference ampersand, and then you write the code. I forgotten the syntax ampersand. I need to put star inside and so on. But that is syntax. But you need to know it has to be. You need to pass the address, and once you pass the address, then you manipulate the variable assigned to A. That is what is being done here. Is that clear? So, I think you should look at some simple C tutorial and do it. Python does make people lazy, is true, but Python also the exchange, if you do not do it carefully, it will not work. Python has same problem as C, but it in fact is slightly more problems with variable passing. Okay. Is it clear the part now? Okay. So, let us move on. Okay, starting recording. So, this is a diagram for thread and blocks and grid. So, Python, well, sorry, in GPU can have millions of threads, literally. I am not millions of threads is possible. In CPU, normally thread is number of cores, right? In, well, I mean, we can pass in a CPU, in a grid, in a node, we can have maximum 64 cores or maybe 128 cores. So, 128 threads for parallel computing. But in a GPU, there is a hierarchy of threads, thread hierarchy. So, first make grids. So, grid of blocks, right. So, this wavy line is a thread. Okay. I would have preferred arrows. So, those old Mahabharata, like, one arrow becomes 10 arrows and 10 arrows. So, that they are, but any thread is, each thread can do work. Okay. So, this is like these threads. So, we have these threads. So, block has many threads. Okay. So, you can see this block 1 1, this block has threads which are inside. So, grid is set of blocks and each block has threads, and for parallel computing you want to run these threads simultaneously, and if you have 10,000 threads, 10,000 work is being done simultaneously, and that is power of GPU. So, I make the example of the square grid of soldiers, which is true, that is being done here, and they do work simultaneously. Okay. I will do that. I mean, benefits of threads in the next class. There are some more, it has more power, okay, synchronization, coherence and all that is there, but that we will do in the next class. So, we can use these threads to do things simultaneously. In the old example, which is a trivial and useless example, we are adding two numbers. That is not what GPU is meant for. GPU is meant for adding, multiplying big arrays. I want to add two arrays which are big size, 10 power 8 numbers. In fact, that will be homework. You need to find out how much time will it take to add 10 power 8 numbers on that NVIDIA GPU. Okay. So, what will I do if I want to add these numbers, large numbers? So, I will create threads, and in fact, lot of threads, but so each block has only 32 threads. Well, you can have 256,000 as well. Okay. So, but not beyond 1000. So, each thread block has only maximum 1000. So, these numbers, this is number of threads and this number of blocks, this number of threads. This number I believe cannot exceed 1024 or 2048. You can't have more than that many threads in a block. So, that will depend on the GPU, but there is a limit on how many threads each block can have. So, they are structured, and so the threads within a block has certain properties, but threads outside the block has certain properties. Like for example, threads within a block can share some memory, but not two threads from different blocks. Okay. So, we are not getting there right now in the today's class, but all that features come handy when you do more complex operation. But all these threads work very fast and they work together. Okay. So, right now just think these are as arrays A, B, C. So, I am sending the address, and then so I have block, but I use only one thread per block. It is a waste of other threads, but this is an illustration. Okay. We go slowly and understand how the code works. So, I am using lot of blocks, these are blocks, and I use one thread per block. That is why I had 1 comma 1 when I was using that example, one thread in a block. So, I need only one thread to add numbers, well not numbers, add two numbers, right. This thread is in fact it uses, well it will tell the core that you add these two numbers and update this number. So, the computation is done by a core, but the instruction is A plus B equal to A, and one core can do it with one thread. But if a large, if you have, well I mean right now I am using only 10 numbers, but if you array of n numbers, then I can use n threads, right. So, I am using, in fact for this example I use n blocks with one thread each, and the syntax for this is here. C, this block id dot x is also a keyword. You can't use that word for your own variable name. So, every block, so this is block id. Okay. So, I have 10 blocks, and each block thread in each block is the single thread is basically adding A and B of its own data and updating, well not updating, is writing into C. Is that clear? So, there this block, first block, so it has A, B, C. So, A, B added and stored in C. This guy A, B added, stored in C, like this. So, I will have 10 of these operations being done simultaneously. Please keep in mind that there is no loop, right. So, this add operation is being done by each of these threads, and this is just one line. Okay. So, when I call this one line, so you created so many, well basically when I call I just give this how many blocks and how many threads. So, CPU says, well this many things are to be created inside the GPU, and all of you do it together simultaneously rather, okay, each on their own. So, there is no loop required. Okay. Please keep in mind there is no loop or threads. So, this is not like multi-threading. Multi-threading had a loop. Okay. So, the main code looks like is slightly longer because I am using arrays now. So, let us look at the main code. So, by the way, it is very similar to what, I mean if you do it for a single number, you can do it for an array. So, let us go slowly. The number, well the line which is different, which you need to see is this line, add n comma 1, n is a number of blocks, one thread per block, and these are the 3 arrays A, B, C, array pointers in fact, okay, and that is being passed. So, it will create n blocks in parallel and they will do their work. Now, other code is pretty trivial. So, we create 3 pointers for the main as well, okay, this for CPU, this for GPU, and size I just keep a new variable integer n star size of int. Then CUDA malloc, device A, device B, device C are pointers of the full memory of size. This will be how many bytes? 10 integers, 40 bytes. Similarly, I create for A, B, C but these are in host and these are in device, host. I initialize them. So, A I is I, B I. So, this is straightforward, you can do whatever you like. I am not putting random numbers here, but okay. Now, after this you need to copy A and B to the device. CUDA mem copy A to device A, div A, and B to div B. Okay. So, this host to device, fair enough. Then you execute this addition, this is happening inside the GPU. Then my result is now in C, inside the GPU, dev C, result is here. Then I need to bring it back to host. So, dev C to C, they are pointers, the C is a pointer, dev C is a pointer, we need to pass pointers, and then I print it. Main host is printing it, and free ABC, free the CUDA memory, and done. Okay. So, this is a CUDA code for arrays. No local sum is, well, right now I am not summing it, sum will be done in the next class. Okay. Sum is more complete operation. Here Ci is Ai plus Bi, that is it. I am not doing the sum. I am not, well, I am not required to do the sum for this problem. Sum will do it, sum is more complicated. Okay, once you are done, then we can, well, this is a, the printing you see the deep Ai plus Bi is equal to Ci. So, it is being printed and it works. Okay, I mean this is trivial code, it works. So, I use blocks which is not good, I should more threads. Okay. So, let us use threads. So, instead of n comma 1 I will use 1 comma n, that is the only thing I am going to change, and instead of block ID I am use thread ID now. So, in the example before it was n comma 1 and now I am going to use 1 comma n, but in the next class I will use both are not 1. Okay. So, that we will do it in the next class, we slowly will build. So, thread ID, just in a given block I have only threads, and there is only one block. So, I can just add the A thread plus B thread is C thread. So, thread is the index, but when I have more blocks, then I need to get the index for different blocks. Okay. So, then there will be something here, but not right now, and call is just this 1 comma n, 1 block and n threads. So, the code remains the same except this is changed, only one line change.